Alright, to round out chapter 2, we're going to be talking about the 68, 95, 99.7% rule to estimate the proportion of values in a specified interval, or the value that corresponds to a given percentile. We'll then also find the proportion of values in a specified interval, find the value that corresponds to a given percentile, and determine whether a distribution of data is approximately normal. So one family of density curves that we will be using all throughout the school year are called normal curves, or also normal distributions. A normal distribution is essentially just a symmetric density curve. So we have two examples here, one that is quite spread out and one that is not so spread out. So a couple of characteristics of normal curves. All normal distributions have the same overall shape. They're symmetric, single-peaked, and bell-shaped. Their center is represented by mu and is the midpoint of the density curve. The variability is labeled as standard deviation. So a normal distribution is quite important for three reasons. Normal distributions are good descriptions for some distributions of real data. For instance, scores on taking a test like the SAT or the ACT. Repeated careful measurements of the same quantity like the diameter of a tennis ball. Characteristics of biological populations such as lengths of crickets and yields of corn. Normal distributions represent a lot of things in the real world, so that's why they're so widely used in statistics. Also, they are good approximations to the results of many kinds of chance outcomes. So flipping a coin many times, rolling a dice, flipping cards. And then also many inference methods that are used in statistics, which we'll be going over in chapters 8 through 12, are all based on normal distributions. So if you don't have a normal distribution, then none of those methods would work. You would have to look at something else. Alright, so hopefully in class you did a little exploration activity where you're having to count up some data points and come up with some percentiles. The point of that activity was to come up with what's called this empirical rule, the 68, 95, 99.7% rule. So through that activity, you're supposed to hopefully find that approximately 68% of observations fall within one standard deviation of the mean. So here in the center is approximately 68% of our data. Then you found that approximately 95% of the data falls within two standard deviations. Okay. And then last, that approximately 99.7% of the observations fall within three standard deviations. Now again, these are approximations. Later on in the school year, we'll get to exact values, but for now, they're just approximations. But these are three values that you need to pretty much have memorized. Okay, now remember that this only applies to normal distributions. If you have a skewed distribution of any kind, these approximations do not work. Alright, so finding areas in a normal distribution. So here we have those ITBS test vocabulary scores. And we are looking at the value of getting a 6 on the score. So remember that standardized score formula, or z-score formula. Well, now we have some other ways to write this. Instead of value minus mean, we can write x minus mu, because remember mu represents mean, and then standard deviation is sigma. So if we standardize all the scores, what happens is that mean 6.84 becomes 0, because a score minus the mean, if the score is the mean, that's 0 divided by something, which is just 0. So all of these values that were 1, 2, 3 standard deviations away are now marked as 1, 2, 3 standard deviations. Instead of their score value, it's standard deviation values. So 6, a score of 6, is represented by negative 0.54 standard deviations to the left of the mean or lower than the mean. So how do you find the area? So if we wanted to know like the percentile of that score, what percent of people did that person score above, kind of thing. First you draw a normal distribution. Then you're going to perform your calculations, and we're going to do that two ways, using a table of values called Table A, which you'll be handed in class, and then also using technology, using your calculator. We're going to always go over both ways, how to do it by hand and how to do it in the calculator, so that you have options, and it's whatever you're comfortable with. Neither of them is more correct than the other. However, our table is going to be more of approximations, and our calculator is going to be more accurate. On the AP exam, both are valid. You just have to be consistent. Then step 3 is going to be that you answer the question. That means you have to write a sentence. Okay, just giving a value is not going to give you full credit on the exam. Like I said before, this is a little bit of English and a little bit of math all together in one class. Okay, so here's our problem. The distribution of ITBS scores, vocabulary scores, among all Gary, Indiana 7th graders. Recall that the distribution is approximately normal. We need that this says approximately normal so that it can trigger our minds to say, oh, it's a normal curve. We have that 68, 95, 99.7% rule that we could use. It tells us that the mean is 6.84 and the standard deviation is 1.55. The question that we're being asked is what proportion of these 7th graders have vocabulary scores that are below 6th grade level. It's very important that you know if you're looking above or below. So the first step is going to be to draw the normal distribution. So we have the original graph, and then we have our normal distribution. Okay. Now we still have that standardized score negative 0.54, which represents that 6. Okay. Now the reason why we can't just find it as a percentile is we're not given the data set. If we were given the list of scores, we could easily figure out the proportion. But we don't have that here. So that's why we have to learn another way. So, performing our calculations. So we need to standardize the value, which we've done. Now you are given a table called Table A. We're going to use this table to find the proportion of 7th graders that have vocabulary scores that are below 6th grade level. Now on your sheet at the top, there's normal distribution, and it shows a Z and area that is shaded. Notice that the area shaded is to the left of the Z value. That means all the proportions are what are less than. Okay? All the proportions that are inside that table are telling you less than values. If you want to know greater than, you want to know this part. Remember, this is a density curve. So to find that, you would do 1 minus what's on the left side. And we'll see how to do that in a moment. Alright, so good to remember that every value I see is going to be less than, is going to be below. So since this is asking me below, that means the value I find is my value that I'm looking for. So to do that, we need to know our standardized score. So our standardized score was negative 0.54. So make sure you're on the correct side of the table. One side of the sheet is positive, one side is negative. So you go to the first column. The first column is going to have your ones place and your tenths place. So for us, that's 0.5. So you go down the first column to where you see 0.5. Found it. Now we're going to go across the row. The row is going to be our hundredths place. So for us, that's 4. Okay, so we went down the first column and found the row that corresponded to 0.5, negative 0.5. And then we went across that row and we found the column that had our hundredths place. Now you see the overlap. That value represents the proportion that are below 6th grade reading vocabulary level. So that's how you use your table. Now, your calculator. In your calculator, you can do just your regular calculate under your scratch pad, or I always do a new document. Do a new document, you need a calculator page, and then you go to menu, statistics, go to distributions, and then you look for norm CDF. So when you find norm CDF, it opens up a parentheses and we have to put in 3 values. We are looking for everything below the negative 0.54. I'm sorry, there's actually 4 blanks to fill in. Okay, so this is our lower bound, upper bound, mu our mean, and sigma our center. So for us, mu is 0 and sigma is 1, okay, because it's a normal curve. Lower bound and upper bound. Well, our upper bound is negative 0.54 because that's our boundary. Now, less than, really this curve doesn't necessarily touch the x-axis, so it could go on for a long time. So lower bound just needs to be something ridiculously smaller than the upper bound. So here you see on the screenshot it says negative 1,000. You could probably put negative 100 and be perfectly fine. Okay, so the lower bound, upper bound, this is our interval that we're looking at. So we could change this up and look for a different part on our density curve. So then when you do that and you press enter, you see you get 0.29459848889. Just a more exact answer than what the table gives us. Again, both are correct, so it's just a matter of which way do you prefer. Now, you can also do the same thing without standardizing it. So that's what part 2 is using your calculator, but do not standardize. We standardize, and we can tell because we're using 0 and 1 as our center and our spread. So we can do the same thing and do our norm CDF, but instead of putting mu and sigma, we put 6.84 and 1.55 as our mu and sigma, because we're not normalizing. It's the exact values that were given about the curve. Now, if we're using the exact values, then when we look at lower bound and upper bound, our upper bound is 6. It is not negative 0.54. Okay, and then lower bound, again, just needs to be a really small number. You could probably go with negative 100 because a negative score doesn't even make sense. Now again, when you do that, you get your same answer, or 0.2939. Decimal is slightly different, but essentially the same. The last part, though, is answer the question. Don't just give the value. So the answer is, we estimate that about 29.4% of Gary, Indiana 7th graders' scores fall below the 6th grade level on the ITBS vocabulary test. We have the value and we have context. You must have context in your answer. If on the AP exam, or even in my class, if I can take your answer and just copy paste it into another problem and it pseudo makes sense because there's no context, it's just a value, you will not get full credit. You must have context from the problem in your answer so that it's clear what you are interpreting or explaining. Okay, so now let's work backwards. What if we have the area, or that proportion that we're looking for, that percentile, and we want to know what value that corresponds to? So we're just going to work backwards. Okay, so steps are the same. We're going to draw the distribution and we're going to perform calculations. So here we have that the heights of 3-year-old females are approximately normally distributed. Again, very important that it says normal. With a mean of 94.5 centimeters and a standard deviation of 4 centimeters. 75% of 3-year-old girls are taller than what height? Okay, so let's make our graph. So we put our mean, we went out 1, 2, and 3 standard deviations on either side. We approximately located where our value that we're looking for is going to be, and we know that the area to the right is 75%. So we're looking for this value of x that tells us that boundary. So let's work backwards using our table. So using your table, what you will do is you will look on the inside and you're looking for a proportion. Now remember, your table tells you the less than. So we're not looking for 75% because that's the greater than part. We're looking for 25. So you go inside the table and you're looking for the value that is closest to 0.25. Now, 0.25, we noticed here before that it's to the left of the mean. So it's going to be a negative value. So you need to make sure you're looking at the negative side of your table. And you need to go and find the value closest to 0.25 inside the table. Then when you find that value, you work your way outside to get the z-score. So you should be getting z is negative 0.67. Now, to do the same thing, or find the same value, but with your calculator, you do the inverse norm. So you still go through a calculator page, menu, statistics, distributions, and you find inverse norm. Now when you do inverse norm, it asks you for 3 things: the area, the mean, and the standard deviation. So again, you have 2 ways to do this. You can do it with the standardized values, so the area is 0.25, the mean is 0, and the standard deviation is 1. And you see you get the exact same z value. Or you can do it without standardizing. And so you have put the area 0.25, the mean was 94.5 and the standard deviation was 4. Now, when you do this option, it's going to give you the final answer. This is going to give you the value you are looking for. If you're not doing that and you're doing the table or the other inverse norm option, there's an added step. Remember, the z value, negative 0.67, is equal to the value we're looking for minus the mean, right? And the mean was 94.5 divided by the standard deviation, which is 4. So if you're using the table or the standardized normal distribution in your inverse norm, you then have this equation that you have to solve for, which is shown right here, right? Multiply by 4 and then add 94.5 over. 91.82 versus 91.8. Very similar in values. So now we need to go through and actually answer the question. About 75% of 3-year-old girls are taller than 91.8 centimeters.